Okay, so your nav plate has a 24 volt light circuit with one 12 volt light for your compass at the top. It's the manual compass. And then you have 24 volt circuits in the second row. And from 12 volt navigation down, it's all 12 volts. You do have some spare breakers, 24 volts, 12 volts. This here is all AC outlets. It's all AC breakers. This is your 230 volt or 220 volt side with your relevant equipment. As you know, your oven is the dedicated breaker, washing machine dedicated plug. Appliances on a boat always must have a dedicated plug. AC outlets, your little sockets on the boat, everywhere on the boat has outlet related to it. It's either the galley or the saloon, or it's your port and starboard outlets like we mentioned earlier. So all your breakers are here for your AC outlets and your appliances. Then you have your calorifiers also connected up here. If I switch them on, we can actually pick up, I think if they haven't, there we go. Now you can see that's your calorifiers and some other loads that's showing you now the loads there. If I switch it off, it'll drop down in a few minutes. There we go. It takes a few seconds to sense. And now you see that's how you can pick up when your calorifier is doing what it needs to do. Okay, you have air cons and plugs and all sorts of outputs. You'll see the loads today because somebody is running a high current draw here. Heat gun, for example, is now running. So that's why you see the 2000 watt. It's not a random spike. It's just seeing what's being used on the system. I've got a crew member here who is heat shrinking the last little bits of cabling here. So that's why we saw that spike. Okay, that's all the lights, mast lights. So your tricolor, your anchor, your steaming, your spreader, navigation lights. This is the little compass at the little round one, manual compass. It's not your B&G compass. Your B&G compass is powered up by your navigation 12 volt backbone. And then you have your courtesy lights on the boat. So this is where you run all your lights from. And if you switch on the breakers on the port and starboard service lockers, you will be able to operate the lights on the port and starboard sides. Your gauges is also a 12 volt gauge system. This is now very nice to have an example here. If you can take a look on the fuel side when I switch it on. So let me just quickly let it go back to its position.
Okay, let's just switch it off. Just down.
Okay. So this is the quickest way to see whether you have a failed sensor or a disconnected sensor. If you look at the fuel gauges, they're not connected yet. So this will happen. It'll go past the full. It'll show you that you have a cable fault or an instrument fail. If it still sees the resistance, for example, if you look at this level sensor, it's got a little magnet that slides up and down, a little floater, activating the certain resistance. At the bottom you will have a 330 ohms, for example, and at the top you'll have 33 ohms. So according to your resistance, this is how the gauge moves, according to the amount of resistance it gets from the sensors in the tanks. Here you have no resistance, so that's why it's showing you a full range here. So if you do get resistance, it will show you this. If you have empty tanks, sometimes the floaters get stuck in a position and your gauge doesn't move. Just open up your sensor and check if your floater is maybe not full of debris or build-ups. Another thing as well, if you've checked and your system is free and it's not moving with the needle, but it's still connected, as you can see the resistance on it, which will be on that side or somewhere on the gauge, not full, then you will know that, okay, maybe my instrument is faulty.
Okay. Useful little tricks to know.
Yeah, just the little small things I had some calls about in the past.
Okay.
Okay, your bilge pumps functions as O2, off, and manual. Okay, leave it in the O2 position always, so it can automatically detect the system. And there's little 5 amp glass fuses in here. Okay, we'll go to the pump in a bit. I want to show you how to do a test function on it and how the float switch works in this case. Okay, so we have a motor, a built-in float switch, and a O2 manual function on our pumps, which we wire up, and then we add an additional float switch with a buzzer should the pump not pump and you don't know. So as soon as it starts flooding, that float switch gets activated and the buzzer will scream. So we'll do that in a few seconds. I think the best will be in the sugar scoop where there's lots of space. Okay, so now we leave it in the O2 function. If you want to, before you go test, usually just come do this. See that it tells you your fuse is working. Okay. In the O2 function, and then we go to the pump. Let me just get down. This is your bilge pump. If you lift up this lid, there's a little pump in there. Next to the wire, you see next to the wire, there's a flat spot. Keep your finger there. Let me just find it. Pump activates. It's a function button which works with your finger induction. This is the O2 thing. Let's say your pump does not pump, but the water is coming in. That's why it's very important to always leave your system in the O2 position. Never have them in the off position, because you will not know when the water goes there. Okay, and then the manual function is obviously somebody must just press the manual button for you and you can hear the pump go zzz. The reason why the manual function does not connect to the buzzer, it will drive you nuts. If you need to say wash in here and you need to drain it with a bilge pump, that buzzer will drive you nuts. Okay, so O2 function. Your alarm is on the O2 function. Should you be asleep and water comes in here.
Cool.
Alright.